scenario of metronidazole. Okay. So, for example, if it is a precision pellet technique, we need to take this metronidazole. I think you have studied in theory. Studied FTIR. IR and FTIR now. Okay. So, if it is you have to do for the pressure pellet technique, then we have to take some small quantity of the sample, and there is a KBR for FTIR. Okay, there is a KBR. Then 10 mg of this one and 10 mg of the KBR. We have to mix it, and then there is a pellet making unit. The pressure, that powder we have to take on the sample holding. Then we have to press it. Then we will form the pellet, transparent pellet. Then we have to keep the transparent pellet in the window of that pressure pellet technique. Okay. So the problem with that pressure pellet is the first thing is a consumable. You need to every time you need to use the KBR. KBR is a costly in that case. For each sample, the costing around 40 to 50 rupees for the KBR only. Once after completion of that experiment, that pellet we have to draw, we have to keep it in the dustbin. So the KBR also we are losing along with sample. Okay, and also time. So you need to mix it and then press it, keeping in the window. It is a time-taking process, and okay, so that's why there is another alternative technique is the ATR technique. Attenuated total reflections. You don't require to any preparation, sample preparation, whether it is a solid, whether it is a liquid, or whether it is semi-solid. Directly, we can go for analysis. Okay, if it is now, it is an metronidazole is a powder form. Okay, it is a solid form. Directly, we don't require to any kind of preparation technique. Directly, take the spatula and keep the metronidazole powder on the window, and then experiment for the FTIR, and then take the print of this one. So now this is the ATR model, and now this is a window, and here we are getting the light. Okay, source of light is from here. Okay, and this is the window, yellow color is looking like. Okay, this is the window, and we are keeping the sample here. Okay, this is the powder form keeping, and then fixing like this. Okay, and this light is passing through sample to this thing and going to the detector. Okay, and detector will detect what kind of sample it is in terms of the absorbance. It will identify the stretching vibrations and bending vibrations which are generated by the particular sample. Okay, so before going for the sample, just I will go background check. Okay, background check for the metronidazole sample. I'm taking for example, maybe this window contains some dust, some other previous samples. So the instrument understood that if you run the background, whatever already is present on that, this will make it zero. Tear, like how your balance you're using tear. So I'm looking at the background measurement. Click just I'm giving the sample name and then background measurement. That will go to 8 scans and make it complete. That is a 0. Okay, now the background is completed. Actually, picture amount.
నాకు రికార్డ్ వచ్చి కాపీ ఉన్నది మేడం రికార్డ్ వస్తుంది మేడం
Sorry, Ramesh Balonde, lab technician. Okay. Actually, we don't require that much sample. Only a window work is sufficient. So now I've loaded the sample. If you want, they can keep it any sample name or sample code or something. Okay, something with data or something. Okay, then start measurement. Okay. So now the light is passing through the sample and then go to the window, go to detector. Okay, now we got this spectra. Then 4,000 watt. I think this is in the AR range. So this is the intensity, and we got the peak here from 1900 to 60 is called as the bending vibrations, and this 1600, 1400, 1500 this is the fingerprint region. Okay. So for example, that metronidazole contains the OH peak. We'll get the peak here. If it's an aromatic CH, we'll get the 2600. Aliphatic CH. There is a standard graph, standard chart table for the FTIR peak. Aliphatic CH, where we'll get aliphatic CH. Aromatic CH. OH functional rules, NH functional rules. Okay. We have to compare this chart with the compounds what we got, so that we can understand, yes, the compound contains NH group. The compound contains aliphatic NH. The compound contains COH group. The compound contains the OH group. So the FTIR is analyzing the functional groups which are present in the given compound. FTIR will never give the entire structure of the molecule. Okay, the OH group will give the information about the OH group. The OH group of the orthophenol also will get the peak. Paraphenol also will get the peak. OH group of other different compound of quinoline that contains OH also will get the peak. Okay, so what you understand that how many CH are there, how many OH are there, whether CH is aliphatic nature or aromatic in nature, or NH, CN, COO, OH of alkali functional group, or OH of aldehyde functional group, or OH of acidic functional group, that also will get information. Presence of functional groups present in the given compound. So usually we do FTIR not only for the characterization of the qualitative and quantitative, but also for the compatibility studies of the formulation. For example, you are manufacturing or you have prepared one formulation of tablet. Metronidazole tablet you have prepared. So what you have to do, you have taken metronidazole and you selected some diluents, some polymer, some diluent, or some other different components. You have pressed, got the tablet. You have to test the tablet for the friability, dissolution, everything, right? In addition to that, you have to see the compatibility also. Correct compatibility. For example, you use the polymer, HPMC polymer. Drug is metronidazole. What you have to do, you have to scan pure metronidazole, whatever used with this like this. You will get a metronidazole spectra like this. And then after that, you have to clean everything and keep the HPMC. Okay, the HPMC spectra like this. Then you take the tablet and make it, take in the powder, make it powder and take the powder here. So that contains HPMC and also both the contents. Okay. Again, you draw the spectra that should contain all the peaks, which contain the metronidazole, which should appear here, and the HPM polymer peaks also should appear here. But no peak should be disturbed. For example, metronidazole contains the 2000 this peak. For example, 2900 this peak. Okay. For example, this peak belongs to OH group of this metronidazole, OH and aromatic ring. Okay. And HPMC that contains the other NH2 peak. Okay. What is incompatibility? This OH of metronidazole and NH of that HPMC is behind any interaction, then that particular formulation is failed, is incompatible. Means one of the functional group is interact with the other functional group of the HPMC. So your formulation, given formulation is failed. So we should know, we are not, these any kind of this functional group should not be interact with any kind of diluent. Then only is a compatible, is a passed. Yes, with that we can identify using by FTIR. Clear peaks of all the peaks for HPMC, all the peaks of metronidazole. Even for the drug combination also, these peaks should not disturb. If it is a disturbing means particular peak is interacting with some other component. Means that peak is blocked, that particular functional group is blocked. So if its functional group is blocked means we lose the biological property. Because that functional group is responsible for pharmacokinetic properties and pharmacodynamic properties. If the functional group is disturbing, you will lose the entire biological property. So that formulation is failed. So we need to go for other polymer or other methods. We have to change the method. So to test the incompatibility, you can use the FTIR here. Got the point? Okay. So that is one of the application. For example, you are synthesizing some drug. You are doing the you are performing one of the steps. The step, for example, how you are preparing the drug of aspirin. You are taking the salicylic acid and distillation of the salicylic acid with acetic anhydride, and you are getting the aspirin. How can you say that the aspirin is generated or synthesized in the that particular bottle or round bottom glass? You are keeping powder, you are keeping reaction for half an hour, and after half an hour you are stopping the keeping mantle, put it in the cold water, ice cold water, you got some solid. You are assuming that the solid is aspirin. What is the guarantee? How can you say that? I am saying that that is only external, what you are taking the acetic anhydride, not acetic anhydride, solid, salicylic. You are collecting again salicylic acid, washed salicylic acid again. How can you say that the aspirin is generated? How can you say the distillation reaction is done, is carried out, it proceeded? Okay, because your molecule is already, aspirin is well-known molecule. We have some physicochemical data, aspirin melting point, color is this much, aspirin boiling point is this one, aspirin melting point. We can, by checking all these things, we can say that maybe that is aspirin. If it is a new compound, first time you are designing, you are synthesizing that reaction, first time you are carrying out this reaction, how can you say that that reaction is proceeded or not? By using FTIR, you can do. Okay. For example, you are doing acetylation reaction, we will get the acetyl functional group, pH functional group. So you definitely will get the peak of pH. If the pH peak is present, then your reaction is maybe completed. For example, you are doing some amination reaction. What is the amination reaction? Your introduction of amino functional group, NH2 functional group. Starting material doesn't contain any NH2 group, but after completion of the reaction, you are introducing amino group by means of some amination reaction. Okay. By final product, if you are testing with FTIR, the amino functional group that is 3400, you should get peak. If you are not getting peak, maybe amination is not completed. Your final product, what you are assuming, that is not completed. Are you understand? Okay. So like this, we can do all synthetic molecules, all the formulations we can test. Okay, you want to determine that what contains what kind of functional groups. For example, what kind of alkylates, what kind of functional groups that contains. That also we can do by FTIR analysis. Or we can do any kind of adulteration process of the food adulteration. For example, honey. You're using honey, marketed honey. Honey contains some is a pure compound. What is the usual adulterant of the honey? That contains that will mix with jaggery. Jaggery liquid usually mixed with the jaggery contains the sugar component. Sugar that contains the OH functional groups, and then whatever that contains the sugar as maybe the fructose and the sucrose. The fructose and sucrose functional groups present in here in the pure sample of the honey means that is a contaminated. We can do for the quantitative analysis, qualitative analysis. We can do some analysis of the oils, edible oils, cooking oils. You can see the your cooking oil. Everyone knows that transferred oils when you're using repeatedly that will spoil. So how can you say that whether spoil or not? By using these we can use by determining the acid value we can determine the quality of the oils. Okay, so like this machine is intended to be utilizing for the determination of particular functional groups in the given compound. These functional groups are basically pH, NH, OH, NH2, CN, COO, aldehyde functional groups or ketone functional groups, all these things you can determine. Okay, so each sample may cost 300 to 350 per sample. The cost of the instrument is around 13 to 14 lakhs. Okay, and like this we can do complete per hour 30-40 samples also. Just only thing is just we remove this one and clean it properly, clean the tip with the sponge and everything, and then again normal sample. You take the print of this one and then go for the next one. Next go for that. Okay, so this is you have any questions? Yes. So this contains deuterium lamp and photovoltaic cell is the reactor. So now the machine ready for the next sample. So we don't require any sample preparation, nothing. This is the beauty of the ATR. Can go for the next sample and then take the print out next sample. Print. We don't require any consumables. And another beauty of can consuming here. Pressure pellet means you are mixing with KVR and then we can't take it back. For example, the sample is very costly. I want to take it back. Then we can take it back to your container. Okay, that is one of the advantage for the ATR. Attenuated total reflectance, ATR means. So the only 50 to 60% of the cost is ATR. The ATR is the interferometer. Yeah, only take the drop of the liquid. There is a window light, yellow color glass. You keep the dot here and then touch. Okay, if it is semi-solid also same. Only gases is not possible. Other than gas, you can do anything. Any questions?
Any accurate value? Accurate value.
No, you only have to cover this place. You have to cover this window, small quantity of the sample. Light. The band, this is called as a visible light. That is from the 1900 to 400. So this is from the say 600 to 2400 IR light, IR bandwidth. Okay, sunlight contains visible light and small part of the UV light also. Okay, like that, there is a light bandwidth. We have a light bandwidth of starts from gamma rays, X-rays, UV light, IR light, and like the microwaves, radio waves. Okay, X-ray lights are the very high, low frequency, just like wavelength is very low. Means we can't visualize with eye. Okay, the X-rays are very small. Wavelength is the one wave. This is one wave, and the distance between the wave is called wavelength. X-rays are very close. For 1 centimeter distance, there are 10 lakhs waves. That's why we are using for the X-ray purpose. I'm keeping the hand. These X-rays is going through the skin, and that's why we are very dangerous. That's why only we are exposing just a shot, and even the family members and also who is the technician also will not be allowed to in the room, because that generate X-rays that will spoil the cells, permanent damage of the cells. So that's why the X-rays is very highly low frequency, very low wavelength. Then follow the visible light, then follow the AR light. Our samples are these are organic compounds will behave differently when they are exposed towards the different lights. The same sample when it is exposed to visible light will behave different. Same sample when exposed to IR light will behave different. Means some part of the molecule is sensitive towards the IR light, some part of the molecule is sensitive towards the visible light. When the same sample is exposed towards the visible light in the UV spectroscopy means that contains the electrons, sigma electrons and pi electrons. Each compound contains the bonds. Bonds are contains single bonds or double bonds. Single bonds is because of sigma electrons. Pi bonds are pi electrons. And the other electrons are the non-bonding electrons. 10 electrons on the oxygen and the sulfur and nitrogen on the non-bonding electrons. These electrons usually will absorb the UV light. Usually all these electrons, when it is in the box, they are the ground state. Okay, for example, if you take the metronidazole contains 10 sigma electrons, 15 pi electrons, and maybe 4 non-bonding electrons. When it is there in the box, when they are not exposed to any light, or are in the ground state, the UV light will be absorbed by the sigma electrons. UV light will be absorbed by the pi electrons. UV light will be absorbed by the n electron. N to n star, like pi to pi star, pi to pi. There is exciting. So there is exciting means there is absorption happens. Absorption happens means what will happen? Now I'm releasing 100% energy here. There is absorption happen here. I'm releasing 100%, 30% is absorbed. Remaining 70% reaches the detector. Detector will detect. 30% absorbed. What is the responsible? Who are responsible for 30% will get the spectrum. So 4 electrons of 5 electrons are responsible for 7% of absorption. 5 pi electrons are responsible for 14% of absorption. Remaining 12% is because of n electrons. That will get the data. Same light, same compound in IR spectroscopy. Electron and electron. Okay, these natural frequency is different from natural frequency of sigma electron. But IR natural frequency is very close to stretching and bending vibrations of functional groups. There is a OH functional groups. There is a OH functional groups always do like this, stretching and bending. These stretching vibrations and bending vibration frequencies are very close to IR frequencies. Then there is absorption takes place. For example, this contains OH. OH peaks will vibrating like this. We are exposed towards the IR light. There is absorption takes place. Then you will get the peak, absorption peak, that is because of OH. Absorption peak. For example, you got the 2400 peak. This is because of NH stretching. 2900 is because of CH aromatic stretching. 1500 CH aliphatic stretching. So that is a still any questions? Resolve చేశారమ్మా? ఓకే, అది HPLC. Anything still? Any doubts? So like this, any pharma industry, any QC and QA usually requires gas chromatography, that is outside is the gas chromatography, HPLC, FTIR, UV, another small all this manufacturing sector. If it goes the R&D, we require the advanced instruments like even LCMS, GCMS, and even like we have, this is FTIR. Another technique is the micro FTIR. The FTIR cost is 12 lakhs. Micro FTIR cost is 2 crores. Okay, and we are associated with IIT Hyderabad under FATI grant. The government of India is giving 100 crores for that grant. IIT Hyderabad is equipping buying some equipment with 100 crores. One of the equipment is a 4D stem. 4D stem costing 34 crores, one instrument cost. Okay, that is the fourth instrument in the globe. Worldwide, there are 4 instruments are there. One instrument is in IIT Hyderabad, and we have access to that instrument. That we can visualize there is just like a microscopic scanning electron microscope, that one. We can visualize the things which are the size of picomoles. The picomoles means you can see your hair, 10,000 part of the air. We can visualize 10,000 parts, 10,000 times smaller than air. We can visualize the mitochondria. We can visualize the basic parts of mitochondria. We are studying mitochondria is like that, like this, like that. And we can visualize the atom. The atom contains proton, neutrons. You can visualize that. Okay, and this is the kind of technology is evaluating. They're also using atom probe. Atom probe has a different application. That is also costing 30 crores per instrument. Okay. So these kind of instruments exclusively is helpful for the R&D when you're developing a new molecule. Okay. Once somebody is developed a molecule, they are giving the procedures and we are manufacturing. In India, all pharma companies are doing manufacturing process. All methods are already established. Drugs and exporting the things. Okay, so for the regular manufacturing, one kind of instruments we require. For complete a kind of R&D, new inventions, we require some other part, some different kind of instruments we require. Okay, the thing is here, how deep you're understanding the things, you'll get the knowledge, acquire knowledge, you will be isolated among 1% or 2% of the chemist or pharmacist. Actually, the regular pharma industry, your entire life, the same instrument, same molecule, same method. There is actually manufacturing process. So there is no chance of doing new things or different things also. You will be placed, for example, placed in the metronidazole tablet manufacturing unit. They are doing daily metronidazole only. You are getting daily metronidazole samples only. You are doing same methodology of metronidazole, same Shimage HPLC, same solvent system, methanol, same metronidazole, same injector, same detector, same sample, same result. But every batch you will get a sample. Per a day, 100 samples you will receive. For 100 samples, you have to run. All 100 samples are metronidazole only. For entire your 15 years of career, same thing. That is what actually the manufacturing. You have to realize that one. You should not be disappointed when you go into the after. Even because why I'm telling is, one of your super seniors 4 or 5 years back, some 3 to 4 members are appointed in the Gland Pharma near Gandimaisama. Okay, they are appointed in one of the QC department. One of the QC department that contains the microbiology lab. మైక్రోబయాలజీ ల్యాబ్ అంటే మనకు ఆల్రెడీ మీకు ట్యాబ్లెట్ వచ్చింది. ట్యాబ్లెట్లో మైక్రో ఆర్గానిజమ్స్ ఉన్నాయో లేదో టెస్ట్ చేయాలి. అంటే ట్యాబ్లెట్లో చిన్న చిప్ తీసుకొని గ్రోత్ మీడియంలో పెడితే మైక్రో ఆర్గానిజమ్స్ గ్రోత్ ఉండకూడదు. ఉండలేదంటే అందులో ఏమీ గ్రోత్ లేదని అర్థం. దానికి కూడా కెమిస్ట్రీ చేయాలి కదా. సో వాళ్ళకి 4 months నుంచి రోజు పెట్టి డిష్ వాష్ చేయమన్నారంట. వాళ్ళ శాలరీ 20,000 బాగానే ఉంది అంతా. salary, everything is they're paying for their role is washing potato dishes and keeping in the oven, drying it and sterile it and keep pack చేసి వాళ్ళు అక్కడ పెట్టి వెళ్ళాను. అదే పని. 4 months అయిపోయిన తర్వాత రిజైన్ చేసి వచ్చేసారు అందరూ. వాట్ దే రీజన్ ఈజ్ డైలీ మమ్మల్ని వాష్ చేపిస్తున్నారు అనే రీజన్. అయ్యే ఉంటాయి, వాష్ చేయటం కూడా జాబే. ఆర్గనిజం అక్కడ ఆల్రెడీ ఆర్గనైజేషన్ ఇనాక్సియేట్ చేసాడు, 10 years వాష్ చేసి అక్కడికి వచ్చాడు. సో 10 అది వాష్ చేసిన దానికి కూడా యూ విల్ గెట్ ద ఇంక్రిమెంట్స్ అండ్ యూ విల్ రీచ్ టు 50,000 to 60,000 salary. సో దట్ వీ హ్యావ్ టు అండర్స్టాండ్, వీ హ్యావ్ టు డైజెస్ట్ అవ్వదు. మీకు మీరు చదువుకునేవన్నీ జస్ట్ బేసిక్ నాలెడ్జ్ అందులోనే చూపించాలి అక్కడ ఉన్న మీరు. అంతేగాని నేను ఎన్ని చదువుకొని నేను ఇక్కడికి వచ్చి వాష్ చేయాలా, ఇన్ని చదువుకొని రోజు మీరు HPLC దగ్గరికి వెళ్తారు, మిమ్మల్ని రోజు ఒక పని చెప్తారు, రోజు సాల్వెంట్ రీప్లేస్ చేయమంటారు. నేను చెప్పాను కదా 51:1 సాల్వెంట్, వాటర్ సగం పోసాను, మిథనాల్ సగం. మీ పని అదే. ఇంకా రావటం, ఆ బాటిల్స్ అన్నీ ఇలాంటి ఎక్విప్మెంట్ ఒక 50 ఉంటాయి అక్కడ ల్యాబ్లో. ఒక్కొక్క ఎక్విప్మెంట్కి 4 ఉంటాయి. దట్ ఈస్ ద యాక్చువల్ థింగ్. సో అలాగే ఉందా? ఓకే. సో విల్ గివ్ వన్ షార్ట్ sample for this. Let me so what we are thinking, we are planning to do accreditation program, training program and HPLC and FTIR hands-on training program for the 1 week is gone. ఇది పోయిందా? Okay. So why I'm keep putting on off this one? This contains a light that will get the 4,000 to 5,000 hours. If you want to replace that, we need to spend again 3 to 4 lakhs. మీరు ఇన్స్ట్రుమెంట్ వాడినప్పుడే దాన్ని ఆన్ చేయాలి. ఓకే. ఇండస్ట్రీలో ఎలా ఉంటాయి, 24/7 ఆన్ ఉంటాయి ఇన్స్ట్రుమెంట్స్ అన్ని, ఏది ఆఫ్ చేయరు. అంటే బ్యాచ్ రన్ అవుతూ ఉంటాయి, ఎవరు ఉండక్కర్లేదు. ఆటో శాంపులర్స్ ఉంటాయి, 100 శాంపిల్స్ లోడ్ చేస్తారు, ఇంటికి వెళ్ళిపోతారు. అది 1 by 1 శాంపిల్ తీసుకొని మొత్తం రికార్డ్ చేసే ఉంటాం. ఇఫ్ యూ వాంట్ యూ కెన్ యాక్సెస్ ఫ్రమ్ యువర్ మొబైల్. ఏం జరుగుతుందో మొబైల్ నుంచి చూడొచ్చు. ఓకే, కెన్ క్లోజ్ ద డోర్. Okay, so now you see I explained at theory. Each instrument will run by the software. We are not doing any handling, anything. That, for example, this is a She-Match. They have their Opus software they're given. And for example, water instrument contains the Empower software. If you want to buy the software itself costs is 10 lakhs. Okay, the hardware pay maybe 15 lakhs is hardware, means software itself is a 10 lakhs driver to run the thing. Okay, so how mobiles are working with the Windows or the software. Exactly how your mobile is updating your software every time, versions. Like that, these also will get the versions and updating, keep on updating. Okay, so now this is the Opus software. This is the pump. We have 2 parts right here. This part is pump. This part is detector. This is the UV detector. 50% of the compartments is exactly same of the UV, general UV spectroscopy. But UV spectroscopy, there is a window and can keep the sample and all. There is no such only, but that contains the UV machine. Okay, so this is the pump. Okay, and this is the detector. Okay, and these are the reservoirs. We have single pump instrument, this one. Usually the instruments up to 4 pumps. This is a single pump instrument. Okay, we can do most of the times isocratic elation. Maybe isocratic elation of the single solvent or isocratic elation of the mixture of solvents. Now I have taken the solvents of methanol and water. 1:1. But I am not disturbing the concentration entire experiment. It is called as isocratic elation. Because even though the solvent is a mixture, okay, but I am not disturbing the concentration ratios. For example, the time is 10 minutes. Entire 10 minutes, I am not disturbing same solvent I am pumping. This is called as isocratic elation. If I am doing first starting with water, then I am mixing some other solvent. After that, I am taking other solvents called as a gradient elation. Gradient, which keep on changing with respect to time. Most of the times, always the better methods will be gradient elation or better method. Okay, so I will explain why it is a gradient thing. So now the pump is on, okay, and it is running 0.7 ml per minute. Can you give that chair? This is isocratic flow. I kept, okay, the pump flow. The pump is pumping 0.7 ml per minute. If you want to increase, I can increase. This is 0.7 ml they are pumping. The pressure they build up in the column, there is a 75 kg of. Okay. So if it is the pump, this column can withstand up to 102 kg of. So we cannot reach to the 102. If it is 102, it reached, it will automatically stop. Okay, now it is a 0.7. If for example, if I want to do 0.6, then make it 0.6. That is the pressure. Volume. Okay, now it's a 0.6. I made 0.6 change in here. Here also change. It means the pump is taking 0.6 ml per minute and pumping towards the column. Okay, so now we see here, this is a column inlet. Here, this is the column outlet. You can see. You see, the solvent is running. So here the pump is pumping, and then it is coming here, and then this is the injector. It's coming to the injector, and then you can see this is the pipe. This is the pipe is pumping, and then going to the injector. It is going to the injector here. Here we will inject here, and this is the outlet from injector. Here it is coming to the column inlet, column outlet. From the column outlet, it is going to the injector. Okay, so from column outlet going to detector, from detector, and there is a waste pipe going to the waste dustbin. Means is now is running. Solvent is taking from reservoir by the pump, from the pump to the injector unit. Here from injector to the column inlet, column outlet, detector, and then drain. So this is actually the mission. Okay, for example, 4 pumps. 4 pumps unte 4 pumps nunchi 4 solvents vasthayi. First pump number 1 from one reservoir that contains water. Pump number 2, second reservoir that contains methanol. Pump number 3, third reservoir that contains the benzene. Pump number 4 that contains acetylnitride. 4 wires ఉంటాయి ఇట్లా. 4 pipes, 4 pumps. ఈ 4 pumps వచ్చి ఇక్కడ మిక్స్ అవుతాయి. How much each pump ఎంత performance ఉండాలి మనం you can fix it. Pump 1, 0.1 ml per minute. Pump 2, 0.3 ml per minute. Otherwise, you can mix it. Methanol, water, acetylnitride 1:1:1, or 1:1:1, or 1:3. You can mix it. Automatically, pump will adjust and run. Okay, what we require the concentration, the pumps will take and will mix it here. All the pipes will mix. So that injector. Then this is called as a manual injector. Even the industry that contains the auto injectors. If there is a tray, keep the tray and close it. And then entire night after the till completion of 50%, every we will get the spectra, and the spectra will recorded in the saved in the folder with the file name. Okay, after that, after coming on here, you can access that and check what is the results you want. That's called auto injectors. All are in auto injectors only. This is the manual injector. Okay. Now you see here isocratic flow and wavelength. What are the sample we are using? Caffeine's lambda max. We have to fix we have to work at the wavelength of caffeine. Caffeine wavelength, for example, 275. If you want to change, you can change here. For example, 273 or 6. Like I want to 374. Or the caffeine wavelength is 240. Okay. If you don't know the wavelength, you can go for the UV spectroscopy and then check the wavelength. Okay. So now this is the pumping is going on. Okay. The Socratic elation, this is fixed, and pump air pressure is recording here. So these are all the parameters. If you want to change any parameter, you can change. Okay. Now this is okay. Now we are getting. Can you bring sample? This is the sample. So this is the peak how we got. Okay, after injecting. So this is already there is a sample that is eluting now. Previously given the sample. Okay. So once injector mode and loading mode, we have to keep it in the injection mode and load mode. Loading and the injecting mode. So this is the needle. Okay. So there is no specific amount of quantity we are introducing. Any quantity you can introduce. So the injector will take, for example, you are taking the 10 microliters, but instrument will take 1 microliter only. If you give the one also will take 1, 2 also will take, otherwise remaining amount will go to the drain. So that is a fixed. So whatever the amount they accidentally or you're injecting, it's very difficult to inject exactly 1 microliter with a small syringe. So randomly we can inject it, but that will take only 1 microliter.
10 mg per 30.
10 mg per 20 ml, 0.1 mg, 0.5 mg per ml. Samples of them. Okay. Okay, so this is in the loading position. Okay, loading over. Injected. Once it is injected, automatically will start from 0. The spectra started from 0, straight line. Okay. Now, for example, now I injected, right? Now the sample maybe is running here. So it is running along with solvent. It's running here, running here, running here. Now we reached here. Okay. So now it is entered into the column. Then the column has the adsorbent of the C18 material. So this material, caffeine is interacting with C18 material and has a binding. Okay, depending upon the binding, slowly it is running. Some of the samples will run fast. If it is a low affinity, it will fast. If it is a high affinity, then slow. Now it is slowly it is running here, running. It will after 1 minute or 2 minutes is running and eluting from the outlet, going to the detector. Now why you're getting the straight line? Detector is experiencing only solvent, only methanol and water. Detector is exposing with only water and solvent right now. That's why you're getting the straight line. Detector is not showing detecting any kind of sample. Okay. Once the caffeine is make it available to the detector, we'll get something, the peak. Absorbance will decrease, change. So that we can record. And the quantity depending upon now we have taken the 0.1 mg per ml. Okay, you will get the one peak. Area under the curve is something. If you increase the 1 ml per minute, 1 ml per mg, that the peak area under the curve will increase. So here we need to construct the standard graph. We need to take the 5 concentrations, how we are taking UV, 5 concentration, each concentration we have to take a spectra, an unknown sample. Then you have to extrapolate this one. You'll get the unknown concentration. For example, this is the caffeine HPLC method as per the IP. There is as per the IP, somebody has demonstrated, somebody has developed, and it is available in the IP. We are following the IP method. We are not doing any change, any columns or solvent. Solvent already they given 1:1 ratio. Okay, columns are already given. Okay, yes, we are also concentration we fixing and they're running. For example, if you want to complete that experiment even faster, then what to do here? We can increase the pressure. If we increase the pressure also, the solvent is flowing. Make it fast. Okay. Okay, and if you want to change some other method, this is called as, for example, 8 centimeters column. We can take the 10 centimeters column. We can take the 15 centimeters column. This one, larger. This column, we can replace this column. Okay, and this is a C8 column. If you want the C8 column. So these columns, each columns are around 50,000. Okay, so depending upon the columns, and even you are handling this one also, it costs 5,000. Okay, so it's very carefully you have to handle, and after that you have to wash it. Okay, with distilled water. Otherwise, what is stuck అయిపోద్ది. Usually, I think this method will get around 4 minutes. I hope, I guess. We get the peak at 4 minutes. After? Yeah, that is a method. How can you say that method now? Or what is the మీ మెథడ్ అయిపోయిన తర్వాత లేబుల్ ఏం పెడతారు దానికి అప్పుడు ప్రెషర్ ఏం పెడతారు ప్రెషర్ ఫిగర్ పెట్టాలి కదా ఆ ప్రెషర్ దానికి ఏం చేయాలనేది ఉండాలి కదా సో అందుకని మీకు ఆటోమేటిక్గా ఫిక్స్ చేసేసుకుంటే ముందే ఫిక్స్ అన్ని రికార్డ్ అయిపోతాయి 4.4 Now you are asking the question, right? What is a carrier? Means now we are used to caffeine, carry out. Now we use a caffeine. వాడేది కూడాను ఈ కెఫిన్ ఆల్రెడీ ఇక్కడ ఉంటుంది మళ్ళీ మనకి పోదు కదా కొంచెం ట్రేస్ అమౌంట్స్ ఉంటాయి ఇప్పుడు మీ ఎక్స్పెరిమెంట్స్ అయిపోయింది నా ఎక్స్పెరిమెంట్ అయిపోయింది యాజ్ కెమిస్ట్ యు ఆర్ కమింగ్ విత్ పారాసిటమాల్ సో దెన్ మై కెఫిన్ శాంపిల్ విల్ ఇంటర్ఫియర్ విత్ paracetamol sample. So then that type of things that is only applicable for the adsorbent of like this kind. This carry out is because of the caffeine sample because of is absorbing the absorbent. Because this is principle is absorption. Okay, the same thing, the principle is like the size dilution. That carry out is different. Okay, carry just before me a sample, our sample effect will be on the course. So then we have to the minimum time of washout period with polar solvent and solar solvent. Polar solvent washout చేయాలి ఎంటైర్ కాలం అండ్ దెన్ ఇది ఉంది కదా దీన్ని రివర్స్ పెట్టి వాష్ చేయాలి ఈ కాలం ఇటు పెట్టి వాష్ చేయాలి సో ద కాలం ఎంటైర్ థింగ్ ఈజ్ లైక్ వీ నీడ్ టు వాష్ అవుట్ ద శాంపిల్ ఎందుకంటే కొన్ని మీకు శాంపిల్స్లో అబ్జార్బ్ అయ్యి బైండ్ అయిపోయినాయి అనుకోండి. సో ఇప్పుడు ఇది సేమ్ డైరెక్షన్లో ఎల్యూట్ అవ్వకపోతే ఆపోజిట్ డైరెక్షన్లో ఎల్యూట్ అవుతాయి, మళ్ళీ బ్యాక్ వచ్చేస్తాయి. ఐ థింక్ ఇట్స్ బెటర్ ట్రై విత్ అదర్ శాంపిల్. మనం ఎంత కెమిస్ట్ ఎంత సేవ్ వెయిట్ చేయాలి ఈ శాంపిల్కి అంటే ఒక 30 lakhs పెట్టి ఇన్స్ట్రుమెంట్ కొని రోజుకి 20 శాంపిల్స్ చేస్తామంటే అది వర్కౌట్ అవ్వదు ఇన్వెస్ట్మెంట్కి ఇండస్ట్రీకి. కెమిస్ట్రీ శాలరీ పే చేయాలి, టైం అయిపోయిందంట. ఓకే, సో దోస్ ఆర్ యూజింగ్ ద బస్ we can move. So what we are conducting the program is like we are selecting 10 students and going to conduct the certification program on HPLC method development. Okay, every day complete afternoon session you will be handling HPLC for the continuous 10 days. This is called the certification program we are conducting. So after completion of that, you are able to handle the instrument from switch on to the taking the spectra, sample preparation, everything. So means you are alone sitting here and handling the instrument. That is actually objective of that program. Okay, so we are going to start with this week or maybe the next week, exclusive for 10 students. It's not possible for handling more than 10 students at a time. Okay, so those who are bus time అయింది కదా can move. హాస్టల్ వాళ్ళు ఎవరు ఉంటే ఉండండి, అదే బస్ వాళ్ళు వెళ్ళిపోండి. ఇంకొకటి ఇంజెక్షన్ ఇద్దాం, తీసుకోండి. Make it 0.6 or something. ఫస్ట్ టైం ఇచ్చిన శాంపుల్ అది, ఫస్ట్ టైం ఇచ్చాం కదా, అది వెళ్ళేట్ అవుతుంది. Means we are getting 1 peak means because we are taking pure sample of checking. If that contains a 2, you'll get the 2 peaks. That contains a 4, you'll get the 4 peaks. Number of samples ఎన్ని ఉంటే అన్ని peaks వస్తాయి. ఇంప్యూరిటీస్ ఉన్న పీక్స్ వస్తాయి. ఫర్ ఎగ్జాంపుల్ ఇది మనకి ఇది ఉంది కదా, ఓకే, ఇంప్యూరిటీస్ అనుకుని చాలా చిన్న పీక్స్ వస్తాయి. ఇది కాలేజ్ ఇంప్యూరిటీస్ చాలా చిన్న పీక్స్ వస్తాయి. Process impurities and stability impurities are again very small quantity of process impurities. Usually we can identify by how the molecule is synthesizing in the laboratory. మనం ఏదైతే మాలిక్యూల్స్ దాని సింథసిస్ వాడతామో రియాక్టెంట్స్ అవన్నీ అందులో మిగిలిపోతాయి. దట్ ఇస్ కాల్డ్ as ప్రాసెస్ ఇంప్యూరిటీస్. స్టెబిలిటీ ఇంప్యూరిటీస్ అంటే డ్యూరింగ్ స్టెబిలిటీ మనం స్టోర్ చేసినప్పుడు దాంట్లో బై ప్రాసెస్ ఆఫ్ ఆక్సిడేషన్ అండ్ రిడక్షన్ దే విల్ జనరేట్. ఓకే, దట్ these samples we have to create the reference standards, we have to buy the reference standards. Each gram 4 lakhs 5 lakhs ఉంటుంది reference standard. We have to synthesize in the laboratory. ఓకే, అవి తీసుకొని మనం కంపేర్ చేసుకోవాలి ఇక్కడ. సో మార్కెట్లో అవైలబుల్ ఉంటాయి మెట్రోనిడజోల్కి ప్రాసెస్ ఇంప్యూరిటీస్ ఏమున్నాయి. దీస్ ఆర్ ద ప్రాసెస్ ఇంప్యూరిటీస్ లైక్ దట్. సో మనకి ఇది వచ్చింది ఫస్ట్ టైం చేసింది. So I'm stopping this one. get around to 10 minutes దగ్గర రావాలి. ఫస్ట్ కూడా 9 minutes వచ్చింది కదా. 7 మరి ఇక్కడ ఇది ఇక్కడ నుంచి ఇక్కడ ఉంది కదా, ఆపేసాం అరౌండ్ 7.5 దగ్గర ఆపేసాం. సో గెట్ మీరందరూ హాస్టలా? బస్ ఆర్టీసీ బస్ ఫ్రీ బస్. హలో చెప్పండి. Like this, instead of mobile phase, we have gas. Outside there are gas cylinders. Usually the gas will store at the high pressure, so we don't require pumps. మనకి పంప్ అవసరం లేదు అక్కడ, ఓన్లీ రెగ్యులేటర్ వదిలేస్తే గ్యాస్ ప్రెషర్తో వచ్చేస్తుంది. సో దేర్ ఇస్ ఏ అవుట్ సైడ్ వీ హ్యావ్ ద పంప్ అండ్ దేర్ ఇస్ ఏ ఇన్సైడ్ మనకి అక్కడ ఈ బాక్స్ ఒకటి ఉంది, మిక్సర్ సిలిండర్స్ అక్కడ మిక్స్ అవుతుంది. సో వీ హ్యావ్ 3 cylinders like nitrogen, we have oxygen and helium we can use. Okay, so what kind of, for example, if you want to mix it, you can mix it. If you want to use one solvent, you can use one solvent. 72.5. So same mobile phase, gas is a mobile phase, and there is no pump and injector, and there is a mixer here and the detector. So here we can use liquid sample. For there we can use gas samples also, liquid samples also. We can gas also, we can give gas sample. For example, in your Daltawad area in the center, you can pick some sample gas. You can find out what is the carbon monoxide, what is the carbon dioxide, what is the oxygen, or any other chemicals eluting by the nearby Aurobindo Pharma. That also, for example, Aurobindo Pharma manufacturing some drugs. They are eluting into the environment. You can pick some gas, smell of sound కదా. ఆ స్మెల్ వచ్చే శాంపుల్ తీసుకున్నారంటే వాట్ కైండ్ ఆఫ్ శాంపుల్ అనేది మనం పీక్ వస్తుంది. So the peak, the shape of the peak should be like this. ఓకే, ఇర్రెగ్యులర్ గా ఉండకుండా షేప్ నీట్ గా ఉండాలి. మనకి ఇప్పుడు ఒకటే ఉంది కాబట్టి ఇట్లా ఒకటి వచ్చింది, రెండు ఉంటే ఇక్కడ ఒకటి వస్తుంది, ఇక్కడ ఒకటి వస్తుంది. ఈ రెండు వెల్ సెపరేట్ అయి ఉండాలి. దట్ ఈస్ కాల్డ్ ద రెజల్యూషన్. Even when you're developing method, still for getting the better resolution, we have to develop a method. Once the method is developed, then we have to go for the validation. Different parameters. So this is a spectra, right? And this is the base area under, this is called as area under the curve. Okay. And, so this is the data analysis. You can put some your college name, your date, your sample, everything. You will get the spectra, you can take the spectra, and where you got the runtime is 4.09. Where is the 4. This is of area is a 70,96,991. This is the sample of 0.5 mg per ml concentration. Then this you can take the print of this one. Okay. Next you prepare 0.1, prepare 0.2, 0.3, 0.4. Okay, 0.1 means 7 lakhs వస్తే 0.2 maybe 10 lakhs వస్తుంది, 14 lakhs, 13 lakhs. అవన్నీ స్టాండర్డ్ గ్రాఫ్ లో పెట్టి concentration against area under the curve, you will get the graph, linear graph, standard graph. Then you unknown sample, bring the unknown sample and inject. That also will get the area under the curve. Then put it in the unknown what is the strength of the unknown concentration also. Otherwise you can keep all these things in the software itself. Okay, you can take the printout of this one, and this is the area. If, for example, if you got the two peaks, one is at 4, 7 lakhs, and some other will get at around 2. Here, one more column will get one. At a 2, maybe is 20,000, 40,000. They based upon the area under the curve. Any questions? So these are all what we can give the sample information. You can write your name, your college name, okay, date, everything will come, and standard sample 1, 2, 3, 4 like this, and take the printout of all these things and connect it. Okay. So and first detector, then pump, put out the pump, and power, close it. So every spectra you can take the print from here. Otherwise directly you can take all the spectra in one page and graph also. Otherwise you can put in Excel sheet in a graph. Okay, so we are doing the manual thing. Usually industry they will construct the channel graph once, and remaining all are samples only. Once only channel graph. All are samples. One channel graph there is a 500 samples. So 500 samples, there is a big tray, and they will fill the sample number 1 to 500 label, and then they will keep the tray inside. Instrument is running 2 days, 3 days it is running. Only they're taking the data, that's all. Samples over means again one more tray. They will remove the tray and split the tray. So we are no need to give, they will not stop the instrument, they will not inject anything. Only thing is they are replacing the mobile phase. Mobile phase replacing also not manual, this is automatic. Okay, only thing is chemist's duty is access the computer and taking the data from the folder. You're copying the folder. You're working on the data only. So instrument is keep on running, same thing. Same method, same parameters, nothing is there. Okay. So the instrument, sometimes the instrument will not stop even after 1 year also. 24/7 will run 1 year only during the maintenance. And here also the entire instruments, whatever handling, is the entire data, what we are doing, when you log in, when you log out, everything will be saved in the water dedicated server. For example, this is a Shimage. Shimage సింగపూర్ లో ఉంటుంది కంపెనీ. వాళ్ళ సర్వర్లో సేవ్ అవుతూ ఉంటుంది. దీనికి ఆన్లైన్ ఇంటర్నెట్ ఉంటేనే ఇంటర్నెట్ పనిచేస్తుంది. ఇంటర్నెట్ ఆగిపోతే మిషన్ ఆగిపోద్ది. ఎవ్రీథింగ్ ఈజ్ విల్ బి రికార్డెడ్ ఇన్ దట్. సో FDA కానీ ఈ రెగ్యులేటరీ బాడీస్ వచ్చినప్పుడు అవి చూడరు. మనం ఇచ్చిన డేటా చూడరు వాళ్ళు. వాళ్ళ దగ్గర ఉన్న డేటా చూస్తారు. మనం ఇచ్చిన డేటాకి వాళ్ళ డేటాకి డిఫరెన్స్ ఉంటే వాట్ ఇస్ ద రీజన్ వై so and so date, so and so chemist repeated that experiment. Why you got this one result? The result is like that, but it's showing like this. So there is a regulation, and sometimes they'll cancel the entire batch. So that's why regulatory industry is a very difficult and also a lot of profits also. But Indian based scale ఏది వచ్చినా మార్కెట్లోకి వచ్చేస్తుంది డ్రగ్. ఇప్పుడు పారాసిటమాల్ 650 mg డోలో 750 ఉన్నా మనం వాడుతూనే ఉంటాం. 750 ఉన్నాయి కూడా ఉంటాయి మార్కెట్లో, 600 ఉన్నాయి ఉంటాయి. బ్యూటీ ఏంటంటే 750 ఉన్నా మాకేం కాదు, అప్ టు 1000 ఉన్నా మాకేం కాదు. 500 ఉన్నాయి, ఎందుకంటే 500 mg టాబ్లెట్స్ ఉన్నాయి, 650 ఉన్నాయి, 1000 కూడా ఉన్నాయి టాబ్లెట్స్. యాక్టాన్ ఇది 1000, అంటే పారాసిటమాల్ సింగిల్ డోస్లో 1000 వేసుకున్నా ఏం కాదు. 650 ఇచ్చాం మనం, 750 అయితే ఏమవుతుంది, ఏం కాదు. 600 ఉన్నా ఏమవుతుంది, 300 ఉన్నా ఏమవుతుంది, ఏమవుతుంది. So there is no problem about this. The regulatory domestic market is like there is no proper practices. Okay. So this regulatory market is not regulatory market is very sick.
Connect tomorrow for the next session and the valid tweak. Thank you for the connect.
Thank you.